Hello everyone and welcome to today's webinar where we'll be taking a look at smart cities and how you can benefit from the data, technologies and collaboration opportunities they bring. My name is Stephen Kennett and I look after the Smart Cities and Built Environment channels here at 2 Degrees. I'm delighted to welcome our two presenters today. From IBM we have Dr. Rick Robinson, Executive Architect for Smarter Cities. We're also very fortunate to be joined by Professor Keith Osmond, Director of Research at Birmingham City University. Today's presentations will be divided into three parts and will last for around 45 to 50 minutes, which will leave us with 10 minutes for questions at the end. Before we begin, I'd just like to remind everyone that you can submit questions throughout the webinar using the Q&A box on the bottom right-hand side of the screen. Just type in your question and press send, and then we'll wait till the end before answering as many as we can. As an aside, if anyone should have any technical issues during the webinar, please use the chat box on the bottom right-hand side to send me a message and I'll get back to you as soon as I can. So without any further delay, I'd like to hand over to Rick, who'll get us started with today's presentations. So over to you, Rick.
Hello, Stephen. Thank you. Can you hear me okay?
Yep, I can hear you loud and clear.
That's great. And my first chart should be on the screen. So I've worked in IBM's Smarter Cities initiative for about the last 4 or 5 years. In Europe and the UK mostly. So I just wanted to give a brief introduction to some of the trends affecting cities as IBM sees them and the reason why we think we have a role to play in addressing them. So the first point is just to note quickly the move to cities that, as a world population, we're making. About 2 years ago, we passed the mark where more than half the world's population lived in cities. In the UK, we're already up around 90% of us living in urban areas. Some of those in towns rather than cities as such. And the corollary of this, of course, is the industrialization of food supply. It's easy for us to overlook this in a developed nation, but if you look in developing nations that are urbanizing at the moment, then they still define urban areas as those with less than 50% of the economy based on agriculture. And so one of the things that means is that as the world's population grows, we're going to see increased competition, not just for economic activity, not just for energy, but in some cases for food and, in fact, fresh water. We already use about 75% of the world's fresh water, feeding the world's population. As the size of city populations doubles over the next 20 to 30 years, we're going to need to either find a lot more fresh water or use what we have more intelligently in order to feed ourselves. So this rapid urbanization we're seeing at the moment has some effects in many areas of life. The other thing I think we're all very conscious of in the recent flooding as well is the increasing impact of climate change. The graph on the top right here shows over the last century or so the financial impact of weather-related events, and we can see it's rising sharply. The cost of weather events is rising partly because there are more of them, but also because as the world's population becomes concentrated in cities, many of them coastal, then each event, when it hits a city, has a much higher impact. And the markets are starting to notice this. This is in the bottom left, you see a survey from last year from the Global Investor Coalition on Climate Change, which surveyed the attitude of fund managers responsible for $14 trillion of assets. And what it's showing is that both asset owners and asset managers are increasingly taking investment decisions or divestment decisions based on an understanding of the risk to climate change of the assets or businesses they're considering investing in. So this isn't quite a sort of switch to proactively investing in low-carbon technology, but it is evidence that the markets and investors are starting to price in climate risk to the decisions that they're making. And then finally, bringing things back locally into a much more human level. This is just one example of some striking work that's been done in several places recently to analyse the effect of where you live on how long you live. This particular piece of work was done by the Centre for Advanced Spatial Analytics at University College London, and what it's showing is life expectancy in various bits of London. If you look across to the right, you'll see in some areas life expectancy is 75 years, and that's correlated with high degrees of child poverty. In other areas around about Oxford Circus, Tottenham Court Road over on the left, you can see that people's life expectancy is 96 years. This striking difference in how long you're likely to live based on where you're born, actually within the same city, is common to many UK cities. It's often about a 20-year difference. Interestingly, if you go and talk to people in Scandinavia about this, they start off looking at you as if you're a bit funny, because this sort of disparity just doesn't exist there. What they've achieved through a system of high taxation, collective insurance, and the culture they have is a very equal life expectancy across cities and across the country. Now, we have an economy that works on a different basis, of course, but I think we can all aspire to try to make cities a more equal place to live by this very fundamental measure. So what's all this got to do with a technology company? Pardon me, have to excuse me, I have a small cough at the moment. One of the things that I think we'll all understand at the moment is that the smartphone, the internet, touchscreen technology is starting to transform the way that people everywhere use information, and that's changed industries such as retail, publishing, and starting to change television. I think some of the technologies we can look ahead and see coming, or that actually are already here, are going to cause even more striking changes across a set of activities and sectors that we perhaps would not expect. So just to demonstrate how much further we've already gone in making information easily accessible, the two pictures in the top left of this chart show some work done by scientists at the University of Berkeley 3 years ago. The image on the right was captured from an MRI scanner measuring the brain activity of a person inside the scanner who was watching the film on the left using a pair of goggles. So this is simply using technology to capture images from someone's mind. Similar technology has been on the market for the computer gaming industry for a number of years now, slightly less less sensitive. So the way in which we use information is going to change out of all recognition over the next few years as the interface to it effectively just disappears. And we can do some striking things with that information. The image in the middle is the IBM Watson computer a few years ago now, competing against human beings in a television general knowledge quiz. This isn't really a demonstration of artificial intelligence. It's a demonstration of what we can achieve using technology to analyze information. In this case, it understood questions that were asked of it in human language by the host of the show, and it had access to Wikipedia, the Internet Movie Database, and other sources of human-readable information. You can see from the scores there that it was very good at doing this. It beat the two contestants there quite convincingly, and Ken and Brad, by the way, are multimillionaires who don't work anymore because they've made so much money playing Jeopardy in the past, so they're pretty good at it. We're now starting to explore that technology for all sorts of other uses in healthcare, in social care, anywhere where there are vast quantities of information. Finally, the item in the bottom right, the 3D printed prosthetic limb, this to me demonstrates the way that these technologies are going to cause convergences in very striking ways between what we currently think of as separate industries. So this object has been digitally designed to suit the physiological needs of the specific person who's going to wear it. It's then being customized by a creative artist so that it has the appearance that that person wants it to have. And it's then been largely printed out and manufactured on a general purpose machine. So in this one object that exists today, we have the healthcare industry, digital technology, manufacturing, and creative arts all in one object. And that for me is a very visible symbol of the changes that are starting to happen right now. So, of course, what IBM's trying to do is to take these technologies and understand how they can be used to change the ways that cities work. And in a little while, Keith will take over and tell you in more detail about a specific project that he's leading to do that. I'll just give two examples very quickly first. This first one is an innovation transport services in Lyon over in France. It's actually using technologies that have been developed over a number of years. In the first case, and shown in the top left, some technology we developed in Singapore, which can predict traffic movements about an hour in advance. So it compares databases of past traffic movements to current conditions and makes predictions about how traffic flow and volume will evolve over the next hour. It's about 85% accurate without tuning in dense situations like cities where there's lots of traffic. And it can help city authorities to manage traffic proactively and to try and prevent congestion occurring. And what we've been doing since is then taking that insight and putting it into the hands of travellers. So Optimod, the service in Lyon, uses this sort of real-time transport information available on a smartphone to help people navigate around a city using hire bicycles, using buses, using trams, and adapting their journey en route to take account of changing conditions. So a really clever way of changing the way that people can move about a city, and in particular encouraging them to use public transport. The other thing that I think we're seeing in this sort of mirrors the convergence between industries, and I've chosen the city of Dubuque in Iowa for this example, are new collaborations within cities. So Sustainable Dubuque is a collaboration between the local authority, community groups, service providers, the utility organisations providing water and energy, and in this case IBM as a technology partner. And what Sustainable Dubuque is about is trying to harness information to allow the city to use its assets or its resources, its availability of energy and water more intelligently. So it's clearly based on smart metering technology, which can tell businesses and households if they're using water and energy efficiently. If you have those two pieces of information, you can detect quite a lot of information about the way that washing machines and other appliances are being used, for example, what temperature they're being run at, and you can identify if people have leaks. And when people are given this sort of information, then to a certain extent they can choose to change their behaviour and become more responsible, conservative users. What we found that was very interesting, though, and echoes nudge experiments done elsewhere, is when we gave people the score that you can see in the top right of the smart metering page there, this Greenpoint score. This compares this household's water and energy usage to an anonymised aggregate of their near neighbours. And we found that people who were given that information were twice as likely in this case to change their behaviour as people who were just told about their own usage in isolation. You need to be very careful, of course, with all this sort of stuff. These schemes tend to work when they are co-created in a place with a community and are part of a community program, that the technology on its own doesn't always have this effect. And there are some examples of similar approaches being tried that have not worked, and in some cases have even sort of worsened performance from this point of view, caused people to recycle less, for example, in one case. But anyway, these I think are just a couple of the examples of the ways we're trying to use the technologies available to us now to create new ways for communities to use energy, create new sorts of city services. But I'll hand over to Keith now, who's leading a very interesting project with a number of cities. I'm trying just to explore how he's going about that in a little bit more detail. Keith, over to you.
Okay, well, thank you, Rick. Good afternoon, all. So I'm Keith Osmond. I'm based at Birmingham City University, and one of my roles here, although I look after our research portfolios, I've got a particular interest in the smart city space, and we run several projects in this area. So what I'm going to do is just run through a few little bits and pieces. I'm going to give you one definition of smart or future cities, and then I'm going to talk about a particular instance of a project called KIC-T that we're running currently, funded through or by the European Commission through something called a climate kick, and I'll explain a little bit about what those are as well, because these are many of the tools that the European Commission is beginning to unleash to help drive innovation in the sustainability marketplace. So I'll talk a little bit also about the role of city data, because as you saw from what Rick had said, many of those applications are driven by the availability of data from the city and from private sector partners, and the ability to combine that data to make meaningful information to drive very interesting end-user applications. I'll then sort of finish off just by talking about really the integration challenges that we're facing within the project, which is a live project. It's not finished yet. We're about halfway through. And also the potential this has, we think, to create a new type of marketplace for both smart city applications and also for smart city data. So that's roughly what I'm going to go through. So smart or future cities, if you Google the term, you come back with 1 million definitions. From our perspective, I think, it's about sustainable economic development, it's about improved quality of life, and it's about the wise use of natural resources. And that's a very embracing definition. But I think, and certainly responding to several of the questions coming in, putting people at the centre of this is absolutely critical, because what we're really doing is supporting people to live economically active and high-quality lives in a reasonable environment. So within the context of this particular project, this is about sustainable working and living. both in terms of the development of the built environment within the city. So as the city expands, as more people gravitate to the city to live and to work and to play, we will need to look at planning tools to understand the impact that's likely to have. But also, as Rick was pointing out earlier, in terms of things like resource security, so food, water, energy, raw materials, and other things. In terms of the operation of the cities, of course, we are talking about much more integrated transport and the need to both reduce carbon consumption to offset global warming, but also to improve air quality and, reduce noise and all of these things that impact on quality of life. And critical within this mix as well, I think, improved governance, which involves citizens, so putting people at the centre of the changes being made in the city, because at the end of the day, they're the people who live and work and play in it. So I guess from our perspective, silly little statement, but cleaner, greener, leaner is a pretty good way to summarise where this particular project is focusing. Now, many of you will be aware that the European Commission funds a huge amount of research, innovation and other stuff. And at the moment, it's within something called Horizon 2020. It's looking at what are termed societal challenges. These are the global challenges or wicked problems that affect us all. And within the context of this particular project, the Smart and Future Cities, then there are three that stand out here: secure, clean and efficient energy, smart, green, integrated transport, and then climate actions to reduce environmental impact of city operations, to improve efficiency of resource usage, and to look at raw materials, both in terms of innovative new materials and reuse and recycling of materials that can be recovered from the existing environment. And that's particularly important in the context of redevelopment within the city, where there's a lot of demolition going in and a lot of rebuilding, and recovering as much as possible from that process clearly makes a vast amount of sense. Okay, ignore the funny little picture, but the many eyes and moving parts, what I'm really trying to say here is that the whole concept of future cities, whether you look at this from the perspective of citizen, or what it's doing for the citizens, whether you look at it in terms of what it's doing for the economy, what does being a smarter city do for the city administration, etc., there are many, many perspectives on this problem, and it's definitely a moving prize at the moment. Okay, so slight change of tack now. So the funding for our particular project comes from the European Institute for Innovation and Technology, called EIT. And the role of EIT, which is a body that has a legal entity in Budapest, is to fund activity that will increase sustainable growth and competitiveness of Europe. And you're probably aware that Europe is increasingly saying we want to fund things that lead to new innovations, new economic prospects for the European Union, and that improve the quality of life of citizens. The way the EIT does this is through the formulation of these KICs, which are really to create this, what's called a knowledge triangle. So if we look at roughly what that is, the way that the KICs look at this is that in order to get innovation to happen, and then to get innovation to market, in order to benefit citizens and the economy, it needs three sets of actors. It needs universities, indicated on this diagram as the higher education people. It needs research performers, some of whom are universities, but some of whom will be other forms of RTOs and the commercial sector. And it also needs business here, because at the end of the day, it's business that takes new innovations to market to generate benefit for the economic union. So from the KIC perspective, there are currently three, and there are more scheduled to be developed. At the moment, there's the Climate KIC, which is focusing on climate change mitigation, something called the EIT ICT Labs, which is a European set of facilities for, as the name indicates, ICT experiments. And there's also, in fact, an InnoEnergy KIC at the moment, which is looking at sustainable energy. And clearly there are resonances between all three of these, but our particular project is focused through the Climate KIC. Just for reference, there are more KICs being called at the moment. For this year, there's a Healthy Living and Aging KIC and a Raw Materials KIC, and there are more planned for the subsequent year. There will ultimately be about 6 to 8 of these things as innovation vehicles. Okay, so the real question for me then is there a crock of gold to be found? Again, goes back to the value of data and the benefits that can be derived from cities becoming smarter and more sustainable. So I want to look now just a little bit about the city data challenge, and many people have talked about this at great length, and Rick made reference to a number of applications where you need to pull data from the city. It's self-evident, of course, that in many cities, data that relates to the operation of the infrastructure is sometimes owned, or we believe it's owned, by the contracted out service providers, utility providers and others. So we tend to think, for example, that the bus operating data belongs to the bus companies, trains, so on. Highways is often locked down in a traffic control system. And there are, within that, commercial sensitivities that can sometimes be extremely difficult. But it doesn't take a vast amount of imagination to realize that if you could begin to unlock some of this data, and particularly if you were able to combine some of this data, then there is huge both operational and commercial value that could be liberated from that. It's a non-trivial thing to do, as we'll explore, but ultimately we should be able to do several things. We should be able to deliver on the open data obligations that cities are being faced with. We should also be able to use this data to drive innovation, both in the delivery of services and the operation of the city, but also in innovation occurring particularly within the digital community and particularly with the SMEs in the software and creative sector. We should also be able to begin to address some of the deficiencies in ICT skills and others within the occupants of the city. The idea of some of the open data hackathons and other things that various cities have run can be quite interesting as catalysts for innovation and engagement. And potentially also the thorny question of, is it possible to generate revenue for cities from the licensing of various data streams, notwithstanding the fact that there are some open data obligations to be considered. So within the city context, the challenge for many is the vertical data silos. Many of these are due to legacy systems which were not necessarily designed with any lateral connections and were often designed without the appropriate metadata, data type definitions and other things that enable you to combine data streams from different silos to get a meaningful picture of what's going on. Within the open data community, again, the sorts of problems that we see more are, well, who actually owns this data? And it goes a little bit back to the previous slide. Does the city actually own the city data or the bus data that's within a contracted out service, or does the provider own it? How do we do open data best in a technical way? Who's responsible for the curation or the long-term preservation of that data? What about responsibility for it? If you're actually going to build business solutions on the back of data provided through an open data channel, how good is it, and who's responsible if some of the data is wrong and therefore, operational decisions or other things are incorrect because of this? And just a throwaway line, really, that some cities are beginning to try to deal with, saying, well, we'll put a large Excel spreadsheet up on our city web page and that's open data. Well, I'm sorry, but it's not in my view. It doesn't really do what we're trying to do in terms of the spirit of open data. So, the Sustainable Cities Challenge, which is really where this project is facing, where the climate kick is facing now. So as Rick was indicating, the migration to cities is putting great demands on natural resources, and particularly the concentration of those. Getting enough water to feed cities can be particularly difficult. Getting enough food in and out from the associated supply chains can be challenging as well. What we're particularly looking at in the context of developing the city is the problem of increased pollution, both in carbon terms but in other forms, and also the resulting damage to the ecosystems, both natural and business ecosystems within the city. So urban planners, the people within cities who are charged with trying to plan development over the next 10, 20, 30 years, need to have tools that focus also on climate awareness and an understanding of what that development will do in terms of the demand for resources by the city, as well as simply looking at things like how much office space can we create, how many houses can we create, where do we need to put the metro stations. And we need to make that whole decision-making process easier and better, not just for the city planners, but also for the communities in the cities who are either driving some of this need for changes in the urban environment or who will be impacted by it. And it's very clear from where we've been working that the idea of creating this scalable platform for assessment tools and data for use by cities around the globe is a really, really interesting proposition, because many of these are shared problems around the world. There's a huge amount of expertise being developed locally, but there isn't at the moment a simple way of actually making that accessible to other users. So the integration of tools is an interesting one, because many, many publicly funded projects, or indeed private funded projects, have developed modelling tools and simulation tools for cities, or for city systems, or for atmospheric pollution modelling, or for other things. In our experience, these typically haven't been designed to be reused. They may have been built for a specific location, or they may have been built with particular types of data delivered to them in particular ways. And they haven't necessarily been built to interoperate with other tools as well. Again, the tools themselves, if we're not careful, begin to replicate the silo approach to the way that data has been managed. It's also proved quite difficult to reuse or repurpose tools that have been built for a specific location or a particular data set. And of course, if you're not careful, this leads to a lot of duplication, where the same type of tool is created in another location, rather than enabling one city to use tools and expertise developed within another. This probably means, therefore, that if there is to be a future approach to do this, we need some better mechanisms and standards for this, and also platforms that will enable this reusability of tools by other cities, and also interoperation of different tools, so we can plug and play different parts of simulation tools together to deal with different parts of the overall picture. The ultimate aim, which we would like to get to, would be plug and play of city data models and simulations, but that's a big ask. It's going to take a bit of getting to, I think. Okay, so we're starting in a small way with this particular project. So it's called KICT, or KICT Transitions, funded by the Climate Kick, and the aim is to plug and play GIS-based data, so it is based on a geographic information system, within the context of city modelling and simulations. As I said, I want to be able to reuse and repurpose data that's been developed across the EU within different cities, within different projects, and potentially then to be able to plug and play different models together. So, for example, if a traffic flow simulation can also feed a noise model, and it can also feed a pollution model, then we are able to look at the impact of changing traffic flow patterns in both a citizen acceptability mode, and also the impact that has locally on air quality and the like. Interoperability is a given through the use of open standards as much as is technically feasible. And again, we have this possibility of a prototype marketplace at the end of the project. So, who's in the project? Well, like most European projects, these form what are called transnational projects, so they include at least 3 member states and a combination of academic partners, corporate partners, cities and SMEs. And you can see in this particular project, it's primarily the UK, France, Netherlands and Switzerland. In terms of the partner contributions, again, I'm not going to go through these in great detail, but we have in here an SME from France called ARIA, which specialises in the modelling of air pollution data. My own university is going to look at public building energy data, which we're leveraging from a previous project called EPIC. Esri R&D, the well-known provider of GIS solutions, is in here providing the ArcGIS server as the underlying GIS data. ETH Zurich is a very, very high-performing university in Zurich, and they're contributing a Java-based modelling framework. Greenhill is a UK SME looking at building assessment and retrofit tools for public buildings. IBM is in here as a major provider of the underpinning software platform for the use of Intelligent Operations Centre, and also helping with a lot of the data integration challenges. Smaller Better Cities from Zurich is an SME that specialises in viewers for 3D city data, and TNO is the well-known Netherlands technology transfer organisation that provides the conduit between universities and the marketplace, and they're contributing a very significant modelling framework with a lot of different functionality. Key thing, though, again, in terms of the engagement of cities and citizens, it's very tempting sometimes within these projects to take a technology push approach. And it's been very clear here that the actual use of the framework and the models has to be to solve problems that are facing cities currently. So the involvement of the city of Birmingham, the city of Utrecht and the city of Zurich is absolutely paramount in this type of project. This very much has to be a user-initiated pull for the problems that are facing the city administration and their citizens, rather than let's do technology to a city, which I think has sometimes been tempting in the past for many, many types of projects. In order to test the interoperability, then each city will use models and tools that come from 2 or more partners. And this will enable us to test the reuse of a tool developed in one city with data from another, and will also enable us to begin to test some of the daisy chaining of models, such that the output of one model feeds the input of another model. The aim of the project is to come up with a future-proof and extensible modelling framework within which we can host a variety of tools, data sources, and simulations in the context of sustainable cities. This is non-trivial, as we'll see, but the key thing at the end of the day is that this has been validated by the city case studies, which are paramount in this case. I'm going to skip over that slide as time is running a little bit short, I think. But the key thing is that what we're really doing here is creating an architecture that enables these things to be brought together, not a platform onto which we have to drag all of the data. And that, I think, is a slight difference to some of the previous approaches. So, joining it all together, apologies for the little macro photographs, it's my hobby. A platform schematic then. So the 2 core components are IBM Intelligent Operations Center and the Esri ArcGIS product. What we're then layering on top of that are the models and simulations from the different partners. The aim then is to be able to plug into the KIC-T architecture models and simulation data from various cities, to then be able to consume those results through the city case studies shown here by the 3 grey squares, but then also to connect to other projects that have been funded by the European Commission, either in the past or which may be funded in the future. And a really nice outcome would be a set of standards that future projects have to adopt in order to enable their reusability within the context of sustainable city planning. I talked about plugins, and I just want to explain that very, very simply. So if we think about, at the moment, a basic model or a simulation or a rule base, or whatever form this thing might take that tries to map inputs to outputs within a city context, the first thing we need to deal with is the ability to plug different data in. So we need input data connectors and containers within which to put that data. So effectively, the little yellow cross is a plug and a socket for data. We need to do the same thing on the output side as well, of course, because the output from one of these models not only feeds the visualization tools to have a look at the outcomes of that particular model or simulation, but enables the output data to become the input data to another model, where the output from one simulation is feeding another. And that's absolutely critical in the context of what we're trying to do. We need also to be able to plug into this thing the actual configuration data for the model, not just the raw input data, for example, not just the traffic flows or the air quality, but actually to put in some of the underlying information about the city itself. These could be 3D maps, they could be building models, they could be a variety of different things. But these are effectively fairly static data, which is then augmented by what is sometimes real-time feeds on the input side. The final part, of course, then, is to be able to take this data out into a set of sync and timing tools to enable one model to be connected to another and to enable a model to run when a new set of data is available, or when, for example, one model has finished its simulation runs and is able to provide outputs to another model. And some of these models can be quite long-running, particularly atmospheric computation and the like, which is based on heavy grid computing and atmospheric modeling. So I guess it probably doesn't need to say that this is actually quite difficult. Very, very different models and simulations have been developed by multiple partners. They were never designed from the outset to be connected together or, in fact, to interoperate. When you attempt to do this, then this ability to partition variable and static data from spatial and temporal issues is quite important. How do you deal with the fact that, for example, the time axis on these models might be very different, or the granularity of data grids within cities can be very different? We certainly need to be able to provide some overall control of the access to different models and data exchange and data caching, and we need mechanisms for synchronizing models and also to handle bulk data exchanges. So this is not a particularly simple thing to do. So where we are at the moment, and this is just to try and show schematically how this might operate, these represent three different sets of applications from three partners, BCU, TNO, and ETH. Here are three sets of tools being provided by the SME partners, two models, pollution model and building model from Greenhill, and the visualization tools from Smarter Better Cities. And so the way we envisage this working together, and is that where we sort of are working through at the moment, those are our core offerings. So really what we're talking about here is a data exchange mechanism, what's called CDEX in this Birmingham City Data Exchange, which actually links together the data connectors on these models, both the little pink arrows, which are the timing and messaging connectors, and the blue arrows, which are actually the data collectors. If we just look at how this works, and so the three case studies which appeared there, the green, blue, and pink cities, those are actually able to implement tools from different regions and different partners with different data. Because in the example of one particular case here, and this is the Netherlands case study, it's actually using the Birmingham tools to display energy data from Utrecht buildings on an Utrecht map. It's using data from TNO to look at traffic flow and noise, and it's using data from models from ARIA with Netherlands Utrecht city data to predict pollution in Utrecht. So it shows really how that through CDEX we're able to connect these different tools, both in terms of data flows and in terms of control flows, to be able to repurpose models delivered in one region to work in another with data from that city. Integration challenges, as you might imagine, well, as I said here, it's a myriad of very, very different moving parts. There are several sets of frameworks to interconnect, and some of these modelling frameworks themselves are quite sophisticated, particularly the TNO model, which is a whole variety of modelling tools. The way we're handling this is the messaging and synchronization between things is being handled using an open standard called MQTT, which is a publish-subscribe architecture, so that a model which is running will publish its data when it's finished, and then the message broker can actually send to other tools subscribing to those data feeds a message to say, hey, model A has finished and new data is available. This could apply equally well to a city posting, for example, new data. When we bring in a new 24-hour energy update, for example, from public buildings, that would trigger a message to those applications who need to know that, to say that new data is available, and you can now run your model to provide you an updated view using the new Birmingham or Zurich or Utrecht data. We're also having to wrap some what were developed as standalone applications with web services and other things to enable those to be readily repurposed by some of the other frameworks. We mentioned also that spatial and temporal granularity issues are quite a challenge, and these have not all been solved yet, but somehow we do have to be able to logically combine data that's been gathered on a different spatial grid or with a different sampling rate in order to be able to reuse that data. And this is not an unknown problem. It does take some quite careful thinking about. The final part is being able to overlay this real-time outputs with a variety of visualization tools. Some of those are data viewers built by partners. Others may be standard portlets for display, for example, through IOC, and others may be HTML4, HTML5, or some apps being developed for mobile platforms from other partners. But as I said at the moment, it's fun. We all have an integration challenge. The Birmingham case study is leveraging stuff that we've done in the past, but it's really bringing together energy data and the simulation being delivered by Greenhill. So this will help us to understand both what buildings are doing now, but what they might be able to do in the future if they were retrofitted or if various energy reduction measures were put in place. We're also taking Birmingham traffic data into the ARIA pollution model and Birmingham traffic data into the TNO noise model to predict both the pollution plumes and noise plumes from cities, where that data will be leveraged actually from the live systems within the city. I don't really want to go through that in great detail, but the public data building flows, we harvest those from reports available from existing BMS systems rather than having to get down and dirty in the back end of somebody's BMS. They tend not to like you squirreling in to building management systems. So the routine reporting that can be automated is then consumed, and we can display that on energy dashboards. These are what we actually built within the EPIC project. So what could KICT do if it works? When it works. Integrated cause and effect modelling particularly. For example, if you were to close a road or a bridge or to do some roadworks to restrict traffic flow, how do those traffic flows redistribute? What's the effect on speeds and journey times, and then the effect on emissions and local pollution, and of course changes in noise to the surrounding citizens? What could you do with public buildings? As we said here, both existing energy usage, and this applies also to other utilities, it applies to gas and water and anything else that can be metered, but also then the potential for use of renewables or retrofitting of solar or rainwater harvesting or grey water usage and other things. And the ability then, if you're going to make changes to the building construction through retrofitting or changing glazing, or you're going to extend the building, what's the visual impact that has, for example, as well as the physical impact? We think also this could create a new marketplace. The ability to plug and play tools means that tool providers could offer those to the platform for other people to use, be it on a licensed basis or a pay-as-you-go type model. It opens up also the opportunity for a data marketplace for cities and private data owners to offer some of that data to the platform to be used by others, again with some quite interesting potential revenue recovery models, both for citizens and for other forms of data owners. So really, KICT and this particular project funded by the Climate is about integrating the here and now. It's not about doing new research, it's about putting the outcomes of existing research together and also building a set of standards that will enable us to better reuse things that are built in the future. A new marketplace for companies developing models and tools and other things, a new marketplace for data, and particularly new mechanisms to extract value in the context of sustainable cities for sharing by the city administration, city businesses and the citizens. Thank you. So I've run slightly over time and I'll hand over to Rick at this point.
That's great. Thank you, Keith. So I'll just give a brief recap, and I'll zoom through this a little bit quickly so that we've got some time for question and answers. So what I wanted to just come back to was in terms of the technology to support some of these ideas, there are three common characteristics. Many ways of using a question, or a case of being a single answer to all the technology solution for all smart city ideas. It's a far too broad a field for that ever to be the case. But there are three common characteristics that we often come across. One is instrumentation, the sensors around physical infrastructure or the environment to measure things, or at a more human level, the smartphones that we all carry about with us and that increasingly allow people to be the source of data. So one way or another, these ideas often depend on the availability of data about cities, about the environment, about our activities within them. And of course, a very important question in all of that is who owns the data and how is it handled? The Government's Information Economy Council is spending some time looking at that at the moment. My personal view is we need to move away from the language of data privacy and towards the language of data ownership, understanding that we own our personal data and then negotiating with how it might be used. Secondly, then, of course, we need to get that data to somewhere. We need connectivity. We've seen great strides in connectivity, of course, in recent years, but it's still not the case that all cities, all areas have equal levels of connectivity, and a lot of work that we need to do on that. And then finally, there's some intelligence to make use of that information. We've often had a focus in smart cities on automated systems that use information and process it and then operate very efficiently and intelligently. But actually, I think there are many more cases where actually what we're trying to use is technology to provide insight to human decision makers, not to take decisions for them, but to help them be better informed and to take more forward-looking decisions. So instrumented, interconnected, intelligent are three common characteristics. And then just very briefly to run through a few examples of how these are being used. So, but perhaps a very obvious example is this city in Canada, which is using this information, these analytics, to manage the city and its physical infrastructure and its assets more effectively. Looking ahead to the future performance of assets that might be expected over the next year, and trying to understand the effect of all the planned initiatives throughout the city to maintain and upgrade them. At a more human level, Medway Youth Trust in Kent is using similar technology to try to take better informed decisions about social care. They're using analytic technology to look at the data that they hold about people, so when they come in contact with a new child who's having some sort of challenge in the education system, they can more accurately interpret the early signals to try and understand, is this a simple matter that can be quickly resolved at school through the teachers, or is there something more complex happening in the child's social context or their extended family? And you can see from the figures here that by using this technology, they're enabling their staff to make much quicker decisions, which creates efficiencies which save money, but also much better decisions that get the right interventions to the right people in a way that really can improve their lives. Taking these a little bit further, Montpellier is doing something very interesting to try to engage citizens with the possibilities that these technologies create. So their Ecocity district is an urban living laboratory that's increasingly instrumented and in which people can access all of this information about the city themselves and create their own uses for it. The city is looking for citizens to engage in the creation of new city services. So, moving away from the idea of top-down planning, top-down service design, to really co-creating with a community of cities how these new technologies might be used. And finally, we're part of a very widespread effort using this in Dublin over in Ireland, where for some time now the Dublin Information Sharing Partnership has been sharing 3,000 sets of data about the city. Some of those data sets are sensitive and access to them is carefully controlled in areas such as social care, where the city is looking to better understand future needs for complex services or for more simple things such as housing stock. But wherever possible, the data is made available as open data so that businesses and innovators in the city can create innovative uses of it. And they're starting to see now the first companies backed by venture capital creating new business models from some of this city data, because having released a broad set of it in Dublin, businesses there can find the pieces of it that are really valuable and allow a new profitable business model to be developed. They can then take that business model to other cities around the world. And interestingly, what they report from Dublin is that actually a high degree of usage of the platform isn't coming from Dublin, it's coming from businesses in China who are simply using it as one of the better available sets of city data to research these new business models. So I think in particularly that these last two examples are great examples of applying this technology in a way that cities, communities, businesses can find their own value for it, not just in order to make city institutions and service providers able to operate more intelligent, more efficient infrastructures. And just to briefly answer one of the questions that I saw in the chat room, are there any barriers to opening up this data? Then not always, no. Sometimes it's very straightforward to make it available, but other times there are barriers. Three of the traditional ones are if you're a transport authority, for example, opening up real-time information about your services might tell people when things are running late, and I personally think that sort of transparency is a good thing, but it can take some time for institutions to adjust to that practice. In other cases, you need to worry about what the consequences of data might be and how it might be used. And so one of the first things that happened in Dublin was that the partners who formed the initiative collectively created some legal agreements that expressed the liability for use of data, because getting that set out was an important part of them being able to release it.
And of course, finally, one of the challenges we sometimes have is when this information is within systems that are part of services that have been contracted out to private sector. In some cases, the costs of making data openly available, because it does usually take some effort, might not have been included in the initial contract. And in some cases, if those costs are large enough, we might need to wait until contracts are renewed so that open data as a principle can be put into them. And many city authorities are looking at doing that. Interestingly, a whole set of US states have recently legislated for that. So I think that's quite enough from me. Time to hand over to Stephen again, and very happy to take any questions and answers.
Fantastic. Thank you very much, Rick, and thank you, Keith, as well. So we'll dive straight into the question and answer session now. We've had lots of questions come in. And Rick, maybe picking up on that last point that you made, but somebody's asked, do you know of any good examples of governments or local authorities who are doing a good job with policy to promote smart cities?
Pardon me. Yeah, so there's several, I guess. Maryland, I mentioned in the chat room, is one of the US states that recently legislated for open data, and the national government there has made some useful initiatives as well. Birmingham City Council, where I live, I think undertook a very interesting piece of work last year when following the work of their Smart City Commission to establish what Birmingham wanted to be as a smart city. That they've not only developed then a roadmap from that was recently signed off from Cabinet, but they also asked themselves the question, what are the changes that we should make to our planning policy and our development frameworks to take account of the smart city agenda? So some of the policies they're looking at there are clearly to promote open data as a requirement of property developers. And I think an interesting one there, although I don't think anyone's quite figured out how to address the state aid challenges, is could we use similar policies to promote physical regeneration to deliver connectivity infrastructure? I think the UK Property Institute estimates that about £14 billion are spent on new build construction each year in the UK. If we could take a tiny fraction of that to start investing in connectivity infrastructure in some of the places that find it hardest to pay for it themselves, then I think that would be a great thing for national infrastructure. And I think just finally, there are many cities around the country now which have some form of collaborative body, the Smart City Commission in Birmingham, the Smart London Board in London, Opportunity Peterborough, there are many others, and most of these have now set out some form of vision and are working very hard on a roadmap to deliver projects. Of course, the next bit we're all trying to work out is how to get the financing in place to help them pursue those roadmaps.
Yeah, if I could just add to that, one of the things that many of the callers from the UK will be aware of is the concept of what are called local enterprise partnerships, or the LEPs, which are going to help city regions, primarily the 39 across the UK, administer their European structural funds, the ERDF and ESF components. So when Rick talks there about the investment priorities being defined, that's great. What's also then very helpful for that is that those are linked to the strategy for implementation of ERDF for infrastructure and some of the ESF funds around skills to actually help with that journey to become a smarter and more sustainable city. Part of ERDF, which again, structural funds, is predicated against low carbon by Europe now in order to help cities make some of these transitions. So I think the direction of travel, both in terms of the thinking of the cities and also in terms of their ability to resource at least some of those costs using structural funds, is actually really positive, and we look forward to some really exciting developments, I think, over the next 5 to 7 years.
Great, thanks, Keith. Next question, someone's asking what barriers are standing in the way of the sort of rapid adoption of smart cities and the associated technologies? And we've got some thoughts around that, Keith?
Yes, and I think there's probably different perspectives from different people, really. In my view, the problem generally is actually it's a philosophy problem. That sounds rather strange, but actually, in order to make the transition, you've got to be fairly clear that the city administration, right up to the most senior people, are committed to that journey. And if you can get that right, the other things flow from it. And so Rick made mention of Birmingham and the fact that the leader is behind what the Smart City Commission has done and also what the Green Commission has done. And that seems to be the very real, driver for this. If one of your most senior people, so in Europe, in the UK, we don't tend to have mayors with the same type of responsibility or clout as you have across Europe, but there needs to be somebody within the authority who is prepared to own and implement and drive because it's the right thing to do. It has to come from the top. It's much, much more difficult to try and get the buy-in bottom up, I think. Rick might have a different set of views on that, though.
No, I think that's all very right, Keith. I completely agree with it. I'll just add a couple of other pieces to it. So, firstly, I think the city leaders have the unique ability, I think, to facilitate or convene a collaborative vision for what a particular city should try to achieve. But then it's not only public sector that's going to be involved in delivering that. I think particularly with public sector finances where we are, we need to unlock private investment to do this as well. And of course, when what we're trying to do is use private investment to achieve social, economic or environmental objectives, not just to create a financial return, then we need innovative business models and innovative investment vehicles in order to do that. I think we're starting to see some of those innovative business models. They've emerged from social enterprise, from the entrepreneurial sector, and we're starting to try to figure out how to scale some of those up. I think then the question of the infrastructure investment, we're still not really at the stage where we've got a good enough understanding or a good enough ability to predict confidently the social and environmental and economic benefits of smart infrastructure to the extent required to unlock hundreds of millions of dollars from pension funds to invest in them in the same way that we know how to do it for physical infrastructure, concrete and buildings, etc. I think we're at the point where we're going to get to that. There's a really interesting seminar in Canada a couple of months ago where a set of pension companies, insurers and city authorities locked themselves together for a few days to come up with a common understanding of what resilient infrastructure meant, because some of them need it, some of them want to invest in it, some of them will be asked to insure it. So those are really interesting developments. I think the last thing I'll say is that the really key challenge here, I think, is trust. We've had the question in the chat room, do smart cities lose focus on people and citizens? And I think that would be something that we lose focus on at our peril. We have to focus on the benefits of these ideas for everyday lives, for people and their families in cities, and start expressing those and build a trust that the technology companies, the local authorities, the investment community are all working together towards the same ends, and that everyone's happy and comfortable with how the profits and benefits of doing that are distributed. We live in a private sector economy, but I think the objectives of this movement are very resonant with communities and with public sector. I think establishing common understanding and trust along those lines is another one of the challenges for us to really succeed in before we really see a sort of scaling up of investment in this activity.
Great, thanks, Rick. I'm conscious of time, but I think maybe we've got enough for just one more quick question, and the question is, several cities are working on creating open data platforms. Wouldn't it be more efficient to create a joint platform for several cities, and how can this be initiated and facilitated? Rick, do you want to tackle that one quickly?
Yeah, that's a great debate. I worked in one city last year extensively where actually they were trying not so much to invest in an open data platform but in an open data community and to stimulate open exchange between innovators and data owners, whoever they were, about how data could better be used in the city. And I think there they were trying to sort of face head-on the challenge that it's difficult to create a business case to make all data open for its own sake. Many of us believe that it should be, but creating a business case based on the financial benefits of doing so, or the economic ones, is much harder. So I think whilst many cities are actively pursuing open data strategies and investing in them, and I think that's an extremely good thing to do, that's not the only way to do it. And there are even initiatives at international scale that are trying to pull together open data about the environment, about the world, about the economy, and make that available to scientists in order for them to research better interventions that might help us all build a more sustainable world for the future. So I think city scale is certainly one level at which this can be done. Companies doing it is another argument that's being made. Then there's the whole Open Government Forum and initiatives at national and international scale. And there are several, I think, platforms already that try to pull together information from several cities. Our own City Forward platform being one of them, but it's not the only one.
Yeah, if I could just comment there as well. I mean, I think it's an interesting question because many cities that we've spoken to worry about the investment they're going to have to make in tin and wires to actually do this. I mean, they worry about the hardware infrastructure. A slightly different tack, I think, on this is it goes back to the fact that the model that I think we're talking about in our project, which isn't necessarily a uniformly useful model, is not that all the data has to be dragged onto a platform, but actually what you do have to have at some point is some form of switchboard or data exchange to be able to access data wherever it's located and whoever owns it, and to be able to intelligently combine that. 'Cause if you're trying to build data stacks from different data owners, the data doesn't all have to be in one place, but you certainly have to be able to overlay the stacks and make sure that things like the metadata and other stuff enables you to make sensible comparisons between things. I mean, we even have a problem that the coordinate systems used in different countries are different. You know, I mean, think about it. The standard we use for the Ordnance Survey for mapping isn't the same as WGS84 for GPS data, or that's used in other countries. So there are some silly things in there, but I think philosophically the data doesn't have to all be in the same place, but we have to be able to drag it into the point of use from wherever it lives and wherever it's curated. I think the distributed ownership and curation and a series of centralized aggregation points is a useful model, but it doesn't work for everything.
Great, thank you, Keith. So that's all we've got time for now, but I'd like to thank Rick and Keith for their time today and for getting through so many questions, and also for everyone who joined us for this webinar. Just to remind you all that a recording of the webinar and the presentation slides will be archived on the 2 Degrees platform, and we'll send out the link to those once they go live. So I hope you all found today interesting and useful, and that you'll be joining us for more webinars in the coming months. So thank you, everyone.